So there was a question on the definition of symmetric and positive definite matrices. I realized that I neglected to define them, so here we go. So a matrix K is symmetric right? A matrix K is symmetric if K equals K transpose. Okay. What this does for us is that in the context of the kind of use we were putting this matrix to, it means that if we consider our vector C, okay, and we compute C transpose KD, this turns out to be exactly equal to D transpose KC, right, where D and C are vectors as defined in the previous segment. Okay, so this is what we mean by saying a matrix is symmetric. Okay, now a matrix is positive definite if, right, and once again let's use the same matrix K. Okay, a matrix K is positive definite if, let's do the following. If first of all we need to pay attention to the dimensions of K here. Okay, so let's do what we had here. Let's suppose K is an n cross n matrix. Right, in the problem we were looking at, we got an NEL cross NEL matrix. Okay, right. So if K is an n cross n matrix, then it is positive definite if and for all D belonging to Rn, right, for all n-dimensional vectors, we have D KD, D transpose KD is greater than or equal to 0. Okay, in particular, okay, D transpose KD is greater than 0 if the vector D is not itself the 0 vector. Okay? The 0 vector is simply a vector with 0 in every single entry. Okay? And then what that means, of course, is that therefore, if K is positive definite, then D transpose KD equals 0 if and only if, so IFF means if and only if, okay, D equals 0. Okay, so essentially the notion of a positive definite matrix is a generalization to matrices of the notion of a number being non-negative. Okay, so if a number or a variable can be either only positive or equal to 0 but never negative, then the equivalent definition of a matrix is positive definite. Well, actually that's not strictly right. It is the generalization of a variable being positive. Okay, that's what makes that is equivalent to a matrix being positive definite. Okay, but anyhow, that is just an interpretation. The important bit is this definition. All right, we'll stop here.